Today I will demonstrate a novel method for hierarchical topic detection that is based on latent tree models. The method is developed by the research team led by Professor Nevin Zhang at the Hong Kong University of Science and Technology. Nowadays, there is a vast amount of text documents in electronic form. The amount is still fast growing. It is desirable to build a system that allows a user to zoom in and zoom out on a collection of documents, pretty much like what we do with Google Maps, in order to identify information of interest. This calls for hierarchical topic detection. Here is a very high-level description of our method. Starting from a collection of documents, we first identify word co-occurrence patterns, and we represent each pattern using a latent variable. For example, Z12 represents the co-occurrence of orbit, Earth, solar, and satellite. Z13 represents the co-occurrence of the words lunar and moon, and Z11 represents the co-occurrence of NASA space, shuttle, and mission. This way, we get all the latent variables at level 1. Next, we introduce a new level of latent variables to model co-occurrence of level 1 patterns. For example, we found the patterns denoted by Z11, Z12, and Z13 tend to co-occur, so we introduce the latent variable Z21 to model the co-occurrence. We keep adding more levels of latent variables until the number of top-level latent variables falls below a threshold. Then we link them up and obtain a hierarchical latent tree model. Each latent variable in the model has two states. Each state represents a soft collection of documents. We interpret it as a topic, and we characterize it using the words that occur with a high probability in this collection and occur with low probability outside the collection. One of the two states is a background topic, so each latent variable gives us one non-trivial topic. The number before each topic indicates the percentage of the document collection which will belong to the topic. Just now I have shown you a toy example. Next I will show the results that we obtain from a larger dataset that consists of 300,000 news articles from New York Times. We select 10,000 words for the analysis using TF-IDF, and we got a model with 10,000 observed variables. For simplicity, we trimmed about 90% of the words using mutual information and got this model with about 1,500 words. The original model has 5 levels. Here we show only the top 3 levels. Those 20 nodes are the top-level latent variables. Each of them and its subtree is colored using a different color. Next, let us take a closer look at the subtrees and see if they make sense. First, look at the yellow subtree. There are 2 branches. In the low branch, we have words such as parent, father, mother, daughter, son, kids, house. It is about family. In the upper branch, we have words such as missing, survivor, love, loved. Those are about things that happen in our families. Next, look at the orange subtree. There are also 2 branches. In the lower branch, the family goes to shopping malls or hotels for breakfast, lunch, dinner. At the upper branch, the family goes home to take care of the room, windows, floors, doors, and clothes. The red subtree has 3 branches. The lower branch is about cooking, the middle one is about recipes and style of cooking, and the upper branch is about utensils. The green subtree is about music and movies. If this picture is not so straightforward, we now give a topic hierarchy example on this part. This is a large group of topics. Basically, it is about movie, music, and their related areas. It is divided into 4 small sections. First is general movie shooting. We can see shoot, stage, scenes, cast studios, and film movie edited here. The second part is about different genres of a movie like documentary, fictions, of Star Wars or Harry Potter, and then animated, cartoon, or tragedy and drama. The third one is more about movie-related domains. Theater and Broadway, as well as channel names, they are for showing these movies. The last one is about music, like concert, rap, jazz, and hip-hop. Movies and musics are firmly connected in entertainment industry and hence are clustered together. This is a concrete example of our topic hierarchies. Each part of this model has its topic grouped in this way. Then we will go through some other interesting parts. In the red subtree here, there is one branch about cars, another about popularity, and the third branch entertainment and artist. In the blue subtree, there is a branch about books, another about types of writing, biography, nonfiction, or memoir. In the green subtree, there is a branch about cruise in the Caribbean and fishing. Another branch is driving to villages and towns. And there are also very interesting parts in this model, but we have no time to go through all of them. If you are interested, please visit the website of Nevin Zhang's group.